In this video, I want to have a look at differentiation of logarithmic functions. So we know that the derivative of log to the base e of x equals 1 over x. So this we established in our last video. So let's have a look at how we can differentiate some more complex equations or functions involving logarithms. Our first question asks us to differentiate the function y equals x plus log e to the x. So our y dash, our first derivative, would just be differentiating each term separately. So the derivative of x is just 1, and the derivative of log to the base e of x is 1 over x. Our second question asks us to differentiate the function y equals ln x, so the natural log of x, minus 8x squared plus 3. So again, our derivative of this would be 1 over x, so we've just used the different notation there, minus 16x, and our 3 just differentiates to 0. We can also apply the chain rule to help us differentiate logarithmic functions. So if we had a function that was y equals log to the base e of f of x, so a function of x inside there, using the chain rule, our derivative would be the derivative of that inside function, so f dash x, multiplied by the derivative of the outside function, which would be 1 over f of x. So simplifying that, we would have f dash of x over f of x. So we'd have the original function in the denominator and the derivative of that original function in the numerator. Now this is actually on your formula sheet as well. So if y equals log to the base e of f of x, which is the same as ln of f of x, then dy dx is equal to the derivative over the original function. So let's have a look at how that applies to some questions. So we've got y equals log to the base e of 2x minus 5. So our derivative is going to be in the denominator, it's just this function, so our 2x minus 5, and in the numerator, it's the derivative of this, so that would be 2. So our derivative of our function would be 2 over 2x minus 5. Our fourth example is y equals the natural log of x cubed plus 7x minus 3. So again, our derivative would be in the denominator, we've just got this function, so our x cubed plus 7x minus 3. And in the numerator, we have the derivative of this. So we would have 3x squared plus 7. We can also apply the product and quotient rules to functions involving logs. So in this one, we've got y equals x to the power of 4 times log to the base e of x. So we're going to use our product rule. So we'd have u equals x to the 4 and v equals log to the base e of x. So u dash would be 4x cubed, v dash would be 1 over x. And then we can go through and apply the product rule. So we've got y dash would be equal to this one times this one. So x to the power of 4 times 1 over x would be x cubed, plus this one times this one. So we would have 4x cubed log to the base e of x. Now we could leave it like that, or we can factorize. It doesn't make much of a difference. So if we pull x cubed out as a common factor, we'd have x cubed outside of 1 plus 4 log to the base e of x. If we have a look at an example using the quotient rule, so in this one we've got 2 plus log to the base e of x over x squared. So our u would be that 2 plus ln x, and our v would be our x squared. So u dash would be 1 over x, and v dash would be 2x. So our derivative then would be v times u dash, so x squared times 1 on x would just be x, minus 2x times this whole term here. So we'd have 2x outside of 2 plus ln of x. And that's all going to be over v squared. So x squared. Oops, sorry, no, that should be x to the power of 4. Now if we go through and expand out that numerator, we'd have x minus 4x minus 2x ln x all over x to the power of 4. If we collect those two front terms together, we'd have minus 3x minus 2x ln x over x to the power of 4. And because there's an x in every term, we can go through and cancel that out. So we can divide everything through by x, and we would end up with our final answer being minus 3 minus 2 ln x all over x cubed. Now the last thing I want you to be aware of is that we can make some questions a little bit easier to work out if we apply our log laws. So for example, in this question here, we've got y equals log to the base e of 2x plus 1 to the power of 6. Now we could go through and use the chain rule to do this, but before we do that, we're going to apply this log law that we can bring that power out the front. So we're going to rewrite this function as 6 times log to the base e of 2x plus 1. And now we can differentiate. So we'd have 6 times the derivative of this, which would be 2 over 2x plus 1. And we could simplify that to 12 over 2x plus 1. Now you could go through and do it without using that log law, but it does make it a little bit easier. But our last example uses a different log law. We could have applied this same log law to our example 6 as well, but I wanted to go through how you can use the quotient rule. So we have this log law that tells us we can rewrite a log of a fraction into the log of the numerator, so x plus 4, minus log of the denominator, so 3x minus 1. Then to differentiate, we can go through and differentiate each of those things. So for this first one, we'd have 1 over x plus 4, and we'd have minus 3 over 3x minus 1. Right, so that's having a look at how we can differentiate logarithmic functions.